To start this off, how I'm going to do is I'm just going to say, remember when we solve basic algebraic equations, and in this case just we have a linear equation right here. So how we solve for this equation, if I were to solve for x, I use the concept of this, and this is what I showed for, I think, my year 10 and my year 11 class, that we do this process called opposite operations to undo the equation to solve for x. So if it's times, we do the opposite, which is divide, and so on and so forth. And then I drew the line there because this was a year 10 or year 11 class, and then almost just about every operation in math, almost, it has an opposite operation. And I did like the opposite of cube root is cubing it, and the opposite of square root is squaring it. So we did, and we looked at linear examples like this. Okay, and we get solutions, which means a value for the variable. Okay, and that was done okay. So in this equation right here, if I were to solve for x, the first thing I'm going to do is take that positive 17 and subtract it from the other side. And the next step I'm going to do to solve for x is divide by the coefficient, which is 8. So let's just pretend that I'm going to save doing all the number stuff till the last step. So basically, to solve for x, when the equation is put together right here, I'm going to subtract 17 from negative 40 and then divide by 8. So with changing the subject of an equation, it's going to be similar to this, except we won't get number values. We won't be able to simplify this. In this case, this would equal, okay, so we'd get negative 57/8 instead of some variable expression. Now let's look at this. Instead of constant terms here, suppose I have numbers, or I mean letters, sorry. In all my examples I'm going to do right here, I'm just going to say make x the subject. That just means, right here, it means get x by itself. Right, so it's set up the same way here. So to solve for x, similar to this equation, I'm going to subtract the b first, and I'm going to divide by the coefficient. So if I subtract b first, and then I divide by the coefficient, which is a, and the only thing difference between this and this is I get a number value here, but I get an expression here. I can't go any more from that. Okay, suppose I want to get x by itself here, and anytime I have that x term within a fraction, that's a times x squared divided by b equals c. So the first step I'm going to do is to get rid of that divided by b, which means multiplying it to the other side. And it automatically looks better because there's no fractions. I want to get x by itself, so now I'm going to divide by the coefficient, which is a. And my last step, since the opposite of squaring is square rooting, keep in mind if I have x squared equals 9, well, I can't have two possible solutions for that x. I can have positive or negative 3 here. Okay, so keep that number concept in mind whenever we square root something, because if it's some abstract formula and it doesn't have to do with a radius or a physical thing, it's going to be the plus or minus the square root of that expression. Alright, this next example here, I'm still making x a subject, not y. So I want to get x by itself. And when x is on the bottom part of a fraction, I need to deal with that because I want x by itself, not something over x. So getting x by itself when it's on the bottom has a fancy name. Just like I got b out from underneath, I multiplied it to the other side. I'm going to do the same thing. I'm going to do the same thing to x. Okay, but before I do that, I have to shift that y over there. So I'm going to have 7 over x equals 5 take away y. And now that rationalizing the denominator is in effect here. So to get that x from underneath the fraction, I'm going to multiply it to this side, and I have to multiply it to the whole side, so I have to use brackets. Okay, So, the opposite of dividing by x is multiplying by x. That's how it shifted sides. And now the x is bouncing all over the place. It's gone from the bottom, now it's over to the right-hand side of the equation. And now I'm one step away from solving for x, which is just going to be dividing by this expression right here. And I'll have x by itself. It's gone to the right side of the equation, but that doesn't matter. Alright, we'll try this example. We'll try making x the subject. First steps here is going to be to get that square root, and the opposite of square root is squaring. And now to get rid of the x on the bottom, I'll multiply it to the other side. And now to get x by itself here, I'm just going to divide by that y squared, and I think I have it. Okay, the last example I'm going to do, we don't need to rationalize the denominator here, because x isn't in the denominator. But it's stuck inside those brackets, and I want to get it out. Okay, and so one thing I can do is I can expand that 2 through, and then I can deal with the x right here. I can add 2a to the other side, and then divide by that coefficient. Okay, so we've got these as examples which follow from just solving basic linear equations. Alright, just the concept of using opposite operations, whatever they may be. And remembering to use plus or minus when we use a square root. And this step of rationalizing the denominator.
Go back up just to your whole.